Hi guys and welcome to my channel. Today we are going to solve another VulnHub machine called SecOS. I've already prepared the environments and it's ready to go. So after making this directory SecOS and bringing up the machine, one of the first thing we can do is to scan for the IP address. So I try to do that. Scan tag I, th1, tag L, and see. Yes, this is 192.168.56.102. This is the IP address of the machine. So I simply do an map scan. Tag V, tag P, tag S, C, tag SV, and tag ON, and after that nmap.out, and I provide the IP address here. So this must be quite easy for us to discover the open ports here. As we can see here, port 22 and 8081 is open on the target. This is open SSH. The version number is here, port 8081. This is a Node.js Express, and we have some kind of web app called Secure Web Apps here. So all we need to do is to visit the web page here. (192.168.56 and 102) on port 8081. This must be HTTP. That's it. So what we have here, hey there, Secure Web App is part of the vulnerable VM called SecOS. Want to give it a try, explore the website, get root and read flag, root flag.txt. So let's check the web page source and see if there is something useful here. Any comments, directory, any hidden content. As we can see here, hrefs/hint is here. Want help? One of the good hints is here, /hint, and /container we have here. Let's see /hint and /container here. /container. Cannot do that. What about hint? Oh, there's something here. Are you sure there's something to see here? Let's see the web page, source, and see what we can find here. Yes, this is clearly a hint for us, which says, I copy these 3 lines here and put it to somewhere. First, the admin visits the website really frequently. Okay. Second, he runs it locally on 127.0.0.1. So, and the third one is CSRF and a URL. I think that's enough. So, as the hint page here says, we have some kind of CSRF attack here, but let us know how we can use it. If I see the other tabs about develop using Node.js and MongoDB, sign up, we have a sign up page here and a login page here. Let me create an account here, for example, kernel, and 123 is our password. For logging in, kernel 123. Yes, we have another 2 options here, change password and messages. Okay, we can send a message to, for example, other users. As we can see here, there are other users here. Spider-Man, Private, Test, and Kernel. So what we have here is Spider-Man is the admin, and I can send messages. Send message, Spider-Man, Pirate, and Test. We can send a message to Spider-Man, which is an administrator. So let me Just test it. A test message. What happens here? Nothing happens here. Another user pirate. Test message. Does not show our messages here. Why is that? And if I send hello, nothing actually happens here. But let us see the change password. So already I have my username here and the password. I said 123, so 321 change password. It just happened. Log out, log in with kernel 321. I'm sorry, 123. Let me, yeah, it works. So 123. Yeah, that's working. 321. Logging in. Yes, that works, and we don't see messages here. We just see messages from other users actually. Maybe it's just not showing us the messages we have sent before. But change password functionality is some kind of interesting. Let us see the actual page here and find out if we send our change password command here. We have a form here. As it is obvious, we have a form and it's sending a request to /change-password here and using method post. It's two inputs, username and password. So it's input block level and we can send the password. So obviously if we see the storage here and we have a session ID here, so obviously it is vulnerable to CSRF attacks. So as we have here, the admin visits the website really frequently. I mean, admin here points to Spider-Man and he runs it locally on 127.0.0.1. And that shows us it's actually visiting the web page on its local. So, and we have CSRF. All we need to do is just provide a CSRF attack payload and send it to Spider-Man, the administrator, and wait for it to actually change its password. Change password is vulnerable to CSRF attack. Let me build the actual CSRF attack payload here, and before that we need to see what happens when we change our password. I changed the password to 123 again, and this is a post request here, sending password 123 to this address here, change password. Okay, so yes, that's right. So all we need to do is to build this payload again and put our desired values in it. Let's do that, and I use a simple editor here. We need HTML here. We need a body. We need form. And for form, we need an action equals to / local address on port 8081 as it says, and change -password. Yes, this is here. Just use it and put it here. We need a method equals post, and we need to input here. Input type is hidden, and name must be, what name does it send? Oh, I just 1, 2, 3, change password. The password, I just use this here. And the value must be 1, 2, 3. And we need another input here, which is type equals submit, and the value submit again. One more thing, we need just script tag here, and we just want to auto submit the request. So document forms that submit, and this is our CSRF payload. We just need to deliver it to Spider-Man as an administrator account, and we expect that Spider-Man password should be 1, 2, 3 after triggering this payload. But we should save this payload on our machine and make the Spider-Man, the administrator account, to call this page we are offering to him. So currently, if I want to log in with Spider-Man account with password 1, 2, 3, it should not work. But try to do that. Spider-Man 1, 2, 3, login is not successful, and we should deliver it with our user and then see what happens. Our result was kernel 1, 2, 3, login, and we should just send a message to Spider-Man here. As another hint, we have here is a CSRF and a regex for a URL. It means that if we send an HTML, a URL for the Spider-Man account, it just triggers it. So we should do that. Before that, I should save this on my machine. Just copy it and make a page like page.html here. And paste this here. This is working a little nicer, and just use this at the end, just like that, and save it again. We don't need this one. We should serve this page.html python-m server on port 80. Before that, let me think. If config this is our address here, and we need to use Python to serve our page. And once we put this address here, it should trigger. I mean, visit here, it's not important. To be our IP address and page.html. Just what we need to do is to Spider-Man send a request and get page.html from us, and it has a CSRF attack payload in it. As we can see here, CSRF attack payload pointing to local address, change password, and changing the password to 1, 2, 3, and it auto submits the form. Let me try that and send it to Spider-Man. If we get any request from here, we should be assured that it is working. Just didn't trigger. Send another message to Spider-Man. No, it didn't work. page HTML, send it. Nothing happens here. Let me change the port, or maybe 8080, send here. Page HTML, send it. We get nothing. We have page.html here, just doesn't do that. Maybe we should use some other ports. Spider-Man. No, nothing happens again. So let me what's going on here. Should work. At least we should see the HTTP request here. Port 80 once again. Messages. Send message to click here. Actually, HTTP. Our IP address, page.html, and let's send once again. It should work. Send it, and that's it. We just got the request from here. I don't know what happens. Maybe we just ignore it and intercept it too soon. It's coming once again on port 80. You just see we have two requests from here, and this is status code 20200, and it just worked. So as we expect from here, we should see that Spider-Man account should have the password of 123. Logging as user Spider-Man 123, logging, and just work. Yeah, that's great. So our CSRF payload just successfully changed the Spider-Man password, and we can now access some more functionalities, users, messages, and don't need this anymore. Yeah, this is the history of all the messages Spider-Man just got here, and test message, what we used, all our request is request here. And I think we just quickly intercepted the Python HTTP server, and if we could wait a little bit longer, we could see the actual HTTP request earlier in the first place. So it's obvious that from pirate your password is crazy password. So what do you say? Okay, Spider-Man password should be crazy password. We can just tell it here, crazy password, copy this one, and let me sync and search Spider-Man @ 268. Yeah, this is the password of Spider-Man. We just logged into the server, and all we need to do is to exploit server and see if we can just become root here. So let me see the ID, Spider-Man. This is the user here, the only user we can access to. And no cron jobs here. We are in Spider-Man home folder, and we see bash history, bash logout, bash rc, cache, forever, mongo, rc.js. This is here. node npm. This is actually running on a home page of Spider-Man 2 GMP. No. And we have VNWA here, Spider-Man. And we can use another search. Spider-Man. And see what we get here. Use the find command to see what privileges does user Spider-Man have. So we prog it on the prog here, home Spider-Man, and all the .node is actually using the node here, Node.js. Server just working here, node-gyp, we don't need it. Spider-Man, npm server static. Yeah, I think this is just how it works. Let's VMWA and internal solo.js license, node module package JSON, public and script server.js, and all these things here. We are seeing that the internal server and the actual Node.js server is just, the code is here. And let me just explore what's happening here. We have server.js, as you can see here, hint page. Yeah, that's page. We just found a hint page. Change password functionality. This is VulnHub to CSRF attack. As you can see here, just changes the password. I think that this is server.js and this is internal server.js. Let me look at internal server.js 2 and internal server.js, and this is just another port. Yeah, this is port 9000. Stat HPLT. Yeah, there's another local service here on port 9000, and this is internal server. Several listens on local address on port 9000. What does this one do? Let's copy the entire text from here and put it into a new page to read it more convenient. So it's just using the regular functions configuration here, app.use. For the routes, we have app.get function, ping.ejs. It's interesting. Update password, app.post slash body IP switch ping status. Yeah, it's just pinging something. I think that, yeah, console.log ping IP, and it's just pinging something. We have a ping functionality here. If we just sent a post request to this address and it checks if there is an IP here, I mean, it means that a request body with a variable IP, it just redirects us into ping status page. And just does the rest. Yes. We can see that if we provide an IP address to it, and if it is not null, we just go to this block and it uses a ping command here, secure ping, command here and the IP address we provided, and just gives us the results. So let us check it from here. We just use curl. We have curl. Yeah, we have curl tag data to send a post request, and we just use IP equals C1 to local address on port 9000. It just worked. We're just providing a post request with the value of a local address for pinging and once, and for variable IP onto port 9000, a local address. Let me just see what happens here. Yeah, one packet transmitted, one received. We're just using whatever the value we provide here, just pings it. Yeah, that's some kind of interesting. If I provide number 2 here, send curl, yeah, that's actually proves it's transmitting what we provide here, 2 packet transmitted and 2 received. So it must be very easy for us to check for a command injection here. And let me think that that's right, it's just vulnerable to command injection, and we got the ID root. So let me think here. Spider-Man, yeah, got the ID root. So what we need to do is to actually, as we can see here, /root flag.txt. I need to provide this value to get the result from here. We can get shell, but we don't need to. Just get the flag.txt from here. And that's right. Hey, congrats, you did it. The flag for this VM is not die. Mickey must not die. That's it. Yeah, we just see that a vulnerability like OS command injection, how does it affect the actual server, and we can see we can run any command here and get the flag from the /root, and this is the ID of root user account, and internal server is just vulnerable to command injection. And we can check another thing here and see this is actually it is very old, Ubuntu 14.04, and we can actually just see for any exploit for this kernel version, but we don't need to. We just got the flag from here, and it was quite interesting. I think it was very useful, and I hope you enjoyed it. Have a good time.